All right, this is Mr. McMurray, and we are here to show you the step up the working power lab, which we started out in the other room. Now, hang on, let me get my data sheet here. All right. First thing, we have one person who's a stair stepper. Well, since you don't have a lab partner and you probably don't have stairs at home, you may not. Feel free to do your own work if you would like to. Mr. McMurray weighs, we're going to say, 200 pounds, give or take a little bit, but it's pretty close. So we're going to say 200 pounds, okay, times 4.45, which is going to make a big number. Okay, and you can calculate that and put there in the number of newtons. Okay, it's somewhere around 900 newtons or something like that. I don't know. But anyway, you get the idea. All right. There we go. Now it says measure the height of one step in centimeters, which we did. And we got 25.7 centimeters times 100th, because we want to change it into meters, or we could divide it by 100 to be the same thing. And so that's going to make it, well, you can calculate that. And so I won't write it down for you, but you know what that is. All right. Now, the stair height, which is this number here. Oh, that's right, there it is, 0.257 meters, okay, times the number of steps. And we said there were, I believe, 5 steps. All right, so down here you would put this 0.257 meters times 5 steps, and you'll put this is the number of meters. So basically, this is how many meters off the ground my body was lifted, okay? The force that it would take to do that is the weight of my body in newtons, which is up here, and the distance would be the number of steps times 5, okay? Now, I also moved forward, but it's harder to measure that, so we're going to measure how far we lifted me up, okay, as I walked up the stairs. I did that much work to lift my body up to the top, because remember, work is force, the weight that we had to exert to lift my weight up a certain distance. All right, now we used the stopwatch and we went up and down. Well, we may have done an extra time or two there, but that's okay. All right, so first of all, the force is going to be the same. That's going to be the answer you got up here for newtons, and that's going to go on all of them. All right, the distance would be the 0.257 meters, and that will be the same on all of them, because I went up to the top stairs. You lifted my weight each time, and I lifted, went up the same distance up in the air each time. Time-wise, we're going to use the top one and bottom ones, okay? So we just get the, for walking the first time. All right, oops, that should be seconds. I didn't put seconds there, should have. And 4.67 seconds was the longest one. All right, now, in terms of running, we got 1.76, which was my fastest. And my slowest, we'll put that up there, is 2.22. Whoops. 22, just like in ballet, but not. For some reason, it just clicked out of that, but okay. There we go. 2.22. All right, now if you add these times together, you can divide by 2, you would get the average. Add these two times together by 2 and get the average. Then you're ready to start doing this. Force times distance, okay, for the walk. Now, the force and distance should be the same for both. Walking, and then you're going to do it for running. Force times distance. Then you're going to divide by time. Now, for this one, since we did an average time, we're going to say that this one is divided by the average time, right? So force times distance divided by the average time, because each time we did it, it took a slightly different time. So we're going to take the average of that. All right, then we're going to calculate the power used in running up the stairs, or walking. So you do walking first, then you're going to do running. All right, and then it says convert your power to kilowatts. All right, well, the answer you got up here when you did Newton seconds and multiplied these together is equal to a watt. So if you take your answer in watts, then you're going to divide it by 1,000 to get the amount of kilowatts that you did. All right. So if we set that up as a formula, it would be your answer in watts over 1, okay, times, whoops, I think I'm trying to do crazy things here, okay, times 1 kilowatt over 1,000 watts, and basically you would end up dividing by 1,000, and that will give you kilowatts. Now, once you get to kilowatts, they want you to convert to horsepower. If 1 horsepower is equal to 0.5 kilowatts, then you divide your kilowatts by 0.75, and that will give you your horsepower. Okay? Then if you will answer the questions that are left, and that will be good, and we will be done. All right, basically the idea of this is you want to see that work is force times distance. It does not matter what time you do it in, whereas power is all about how fast you do it. If you do the same amount of work in less time, then it's more power. If you have more work in the same amount of time, you would have more power. Okay, either one of those will give you more power. If it takes you a longer time, or you do less work in the same amount of time, then you have less power. And that's kind of the summary of what we're trying to point out by this lab. So hopefully you had as much fun as I have, maybe even a bunch more, and enjoy finishing the rest of today's assignment.